In this example, we want to find the equation of the ellipse. Our ellipse is centered at the origin, and it has a foci at the point 3, 0, and a vertice at the point -4, 0. So when you're starting a problem like this, one of the first things you want to do is plot the information that you're given, because sometimes that helps you see other pieces along the way. I started to plot the information that we were given. Our center is going to be at the origin. I have one vertice at the point -4, 0, and I have a foci at the point 3, 0. Now keep in mind your ellipses are symmetric, so if I know one vertice is over here at the point -4, 0, this distance here from the center out to my vertice is 4 units. That means I should have another vertice over here on this side at the point 4, 0. And I could say the same thing about my foci. I have one foci here at the point 3, 0, which is 3 units away from my center. So coming 3 units in this direction means I should have another one at the point -3, 0. Since all these points lie along my x-axis, my vertice, my foci, and my center, that means that my x-axis is my major axis. Here I've started to create a summary of the information I have. I have 2 vertices. I'm going to call them V1 and V2, and they are at the points -4, 0 and 4, 0. I have 2 foci. I'm going to call them F1 and F2. They are at the points -3, 0 and 3, 0. I have my center, which was at the origin, and we also know that the x-axis was our major axis. So from here, let's go get some of the values that we need to start building our equation. We know our a value is that distance from the center out to one of our vertices, which in this case is a total of 4 units. We also know our c value, which is the distance from the center out to one of our foci. In this case, that is a distance of 3 units. And in order to get my b value, I'm going to be using the formula b squared equals a squared minus c squared. I know my a squared value is going to be 16, right, that would be 4 squared, and my c squared value is going to be 9, 3 squared. I can subtract those two numbers and take the square root to get my b value. Let's go ahead and start building our equation. We know our ellipse is centered at the origin, so my h and k values are 0. So I know the numerator pieces to my fractions. I have an x squared and I have a y squared. I also know my equation has to equal 1 on the other side. Now on the bottom pieces here to my fractions, I can go ahead and plug in the pieces that I now have. Keep in mind my a squared value is a 16. And my b squared value was 7. So this would be the equation to our ellipse. Let's go ahead and take the information that we have and finish graphing it. We already had these points plotted along our x-axis. The points we need are the ones along the y-axis. We got that information when we were solving for b. Keep in mind your b value was radical 7, or in this case, about 2.6. That's going to be the distance from the center out to the point on our ellipse that's along our minor axis. So from our center, I'm going to go up radical 7 and down radical 7 to get my other 2 points. So the 2 points I'm going to be plotting, my p1 value is going to be 0 radical 7, or about 2.6, and p2 is going to be my point 0 negative radical 7, or a negative 2.6. Keep in mind those are the points along our minor axis. Here they are plotted, and the only thing I have left to do is to go ahead and connect my points to draw my ellipse. Here's the graph of my final image. Remember that you're connecting your vertices, your V1 and V2, to those points P1 and P2. Your foci should be inside your ellipse.